our class is horizontal projection. AB is a tower whose height is h. Of course, it may be y. Y is equal to h. A is the base of the tower and B is the top of the tower. A body is projected horizontally with a velocity u from the top of the tower. The body traces parabolic path and finally touches the ground at the point C. When the body moves, it is subjected to two factors: velocity along horizontal direction, acceleration due to gravity along vertically downward direction. Two factors influence its path. As a result, it traces parabolic path and touches the ground at the point C. Along horizontal direction, its velocity is u. Along vertical direction, it is like a freely falling body. It means its initial velocity is 0 in vertical direction. Okay, first I prove its path is parabola. For this, you must think along horizontal direction. Along horizontal direction, s is equal to x. U is a uniform velocity. Its value does not change. So, velocity v is equal to u and time t is equal to t. Substituting in s is equal to vt, we know this is only the formula for a body moving with uniform velocity. So, substituting in this formula, instead of s, x is equal ut or t is equal to x by u. This is equation number 1. Then along vertical direction, that is y direction, u is equal to 0 because it is like a freely falling body. A is equal to plus g, s is equal to h or y, t is equal to t. Substituting in, s is equal to ut plus half at square. Instead of s, I substitute h. Instead of u, 0. Instead of a, g. H is equal to half g x square by u square, or y is equal to g by 2u square into x square. Y is equal to ax square, where a is equal to g by 2u square is a constant. This equation is similar to parabolic equation, that is y is equal to ax plus bx square. Here a is nothing but 0. This equation is similar to a parabolic equation, so its path is parabola. That is our first confirmation. When a body is projected horizontally from the top of a tower, its path is parabola. Next, I find its a time of descent. Time of descent means the total time it travels is called time of flight, or the time taken by the body to reach the ground from the point of projection is called time of flight. I mean time of descent. To find time of descent, we must think along vertically downward direction. In this direction, u is equal to 0, t is equal to question mark, that is to be found, a is equal to plus g, s is equal to h. Substituting all these values, in s is equal to ut plus half at square, h is equal to 0 into t plus half gt square, h is equal to half gt square, finally t is equal to root of 2h by g. This is the formula for time of descent. One important thing you must notice, there are two bodies, both are projected from the same height but one is projected horizontally and another is a freely falling body. Which body will reach the ground first? The answer is both bodies will reach the ground at the same time, because for the horizontally projected body, the time of descent is t is equal to root of 2h by g. For a freely falling body, the time of descent is same. So both bodies will reach the ground at the same time. Then we find horizontal range. A is the base of the tower and C is the point where the body hits the ground. The distance between A and C, that is x, is called horizontal range. I am going to find horizontal range. To find horizontal range, we must think along horizontal direction. Along x direction, what is velocity? U, that is uniform velocity. Because there is no acceleration in this direction. Time t is equal to root of 2h by g, just we derived. S is equal to x is equal to question mark, that is to be found from S is equal to Vt. This is only formula for a body moving with uniform velocity. On substituting, x is equal to u root of 2h by g. This is the formula for horizontal range. Then our last concept is to find velocity at any instant of time. To find velocity at any instant of time. At any instant of time, let p be the position of the particle and its velocity vector will be along this direction, that is the tangent drawn to the path at the point P. V can be resolved into two components, Vx and Vy. If you find Vx and Vy, then only V can be determined. For Vx, we must think along horizontal direction. Along horizontal direction, Vx is equal to u, which is uniform velocity. To find Vy, we must think along vertically downward direction. We use V is equal to u plus at formula. Here y is for vertically downward direction. Vy is equal to what is initial velocity in vertically downward direction? 0 plus acceleration zt, that is Vy is equal to zt. So I determined Vx and Vy. Then I can find V value. How can I find V value? V is nothing but resultant of Vx and Vy. So V is equal to root of Vx square plus Vy square. V is equal to root of u square plus g square t square. Right, and also I want to find tan alpha. What is alpha? Alpha is the angle made by the resultant velocity with horizontal direction. Tan alpha is equal to Vy by Vx is equal to Gt by u. This is the formula for tan alpha. when the body touches the ground at the point C, V is equal to root of U square plus 2GH, and also tan alpha is equal Vy by Vx is equal root of 2GH by U. So in this discussion we discussed about horizontal motion of a body thrown from the top of a tower. First we proved its path is parabola. Next we determined its time of descent. Then we calculated the horizontal range, and also we determined its velocity at any instant of time. To find velocity at any instant of time, we first find Vx and then Vy. Since V is the resultant of Vx and Vy, then we find V. Formula is V is equal to root of Vx square plus Vy square. Okay, thank you. We meet in the next lesson.